Lesson 46, more on radical expressions, radical to fractional exponents. First thing we're going to talk about is radical expressions. These are problems dealing with square roots. We've done several of these. We've done fractional radicals, and we've done where we had to simplify radicals. And so these problems are combining the two. So we're just going to work our way through an example or two. So the first example, 3 square roots of 5 halves plus 3 square roots of 2/5 minus square root of 90. We want to simplify this completely. So the first thing we need to do is get rid of the fraction inside the square root symbol, because we can't have a fraction in the square root symbol. So we'll start with the square root of 5 halves. Keep in mind that to get rid of the root in the denominator, we multiply by that same root on the top and the bottom. So 3 root 5 halves becomes this 3 square roots of 10 over 2. Next, we want to get rid of the square root of 2 over 5. So we multiply by the square root of 5 on both the top and the bottom. And that gives us 3 square roots of 10 over 5. Now what we want to do is simplify the square root of 90 as far as we can simplify it. So we'll factor 90 down. I'm going to factor 9 and 10. Well, the square root of 9 is 3, and root 10 can't be simplified anymore, so this becomes 3 square roots of 10. And we'll go ahead and put it over 1 for the sake of having fractions. Now what we want to do is go ahead and add, finding a common denominator. So a common denominator between 2 and 5 is 10. So we're going to change everything to have a denominator of 10. Well, 2 times 5 gives me 10, so I'm going to do 3 times 5, which will give me 15 root 10. 5 times 2 gives me 10, so I'm going to do 2 times 3, which is 6 root 10. And 1 times 10 is, of course, 10. So I'm going to do 3 times 10, which is 30 root 10. Now they all have the same roots, they all have the same denominators, so I can go ahead and combine like terms. 15 and 6 is 21, and 21 minus 30 is 9. So the answer is negative 9 root 10 over 10. Let's go ahead and try to work our way through a second example. 3 square roots of 2/7 minus 5 square roots of 7 halves plus 3 root 56. The first thing that we want to do is go ahead and get rid of those fractional radicals. So we're going to start with the square root of 2 over the square root of 7. We multiply both top and the bottom by the square root of 7. And we're left with 3 root 14 over 7. Next, we want to get rid of the square root of 7 over the square root of 2 by multiplying both the top and the bottom by the square root of 2. And that leaves us with 5 root 14 over 2. And finally, we want to simplify 3 root 56. 56 we can factor. And I'm going to go ahead and break 56 down to, let's go ahead and do 2, and that would be 28. I'm going to go ahead and break 28 down to 2 and 14. So I got the square root of 2, square root of 2, and the square root of 14. Well, the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. So this becomes 3 times 2 square roots of 14, which is 6 root 14. For the sake of having all fractions, I'm going to put it over 1. Finally, what we need to do is come up with a common denominator between 7, 2, and 1, and that's 14. 3 square roots of 14 over 7 becomes 6 square roots of 14. 5 square roots of 14 over 2 becomes 35 square roots of 14. And 6 square roots of 14 becomes 84 square roots of 14. Next, we're going to combine like terms. 6 minus 35 is negative 29. Negative 29 plus 84 is 55. And that's 55 root 14 over 14. This next example, I'm going to go ahead and put up, I want you to work this one on your own, and we will come back and check it in class. It's 3 square roots of 7/3 plus 5 square roots of 3/7 minus the root 84. The next thing we're going to talk about is taking radicals to fractional exponents. These are square roots within square roots. Now, there's 2 rules to remember when we're talking about this. The first rule. The power that the number is being taken to is going to be indicated by the numerator. So the power indicates the numerator, and we'll take a look at what this means when we go through an example. And the second rule is that the root indicates the denominator. So the power indicates the numerator, and the root indicates the denominator. Let's look at this via an example. We have the square root of 3, square root of 3. This is a root within a root. So what we want to do, just like we would do order of operations when we're talking about symbols of inclusion, we want to start with our innermost part first. So we're going to go ahead and simplify this root 3 and make it into fractional exponents. This is where we have an exponent that is a fraction. So how we're going to do this is the power of that number is going to indicate the number that's going to be in our numerator, and the root indicates the denominator. Well, if we're taking the square root of 3, inside this is understood to be 3 to the first. So since the 1 is the power, the 1 is going to be the numerator. And we're taking the square root, and so square is going to be the denominator. So this is really the square root of 3 times 3 to the half. Now we want to go ahead and simplify the entire thing. So 3 to the first and 3 to the half is all being taken to the 1/2 power, because we're taking the square root, and the understood power is 1 of all of these. So now we're going to follow our exponent rules. When we have a power raised to a power, we multiply. So 3 to the first raised to the half is going to be 3 to the half. And 3 to the half raised to the half is going to be 3 to the 1/4. We're going to use our other exponent rule that says when we multiply like bases, we add the exponent. Now these are like bases, 3 and 3. So our base is going to stay the same. And what we're going to do is add our exponents. We've got 1/2 plus 1/4. 1/2 plus 1/4 is 3/4. And that becomes our final answer. It's simplified to one root and 1 exponent. Let's look at another example. We're going to do this one with variables, just so we can see. We are going to take the cubed root of x to the 5th, y to the 3rd, times the 4th root of x, y to the 5th. Keep in mind the 2 rules that we wrote down as we go through this. First of all, let's start with our first term. We have x to the 5th, and we're taking the cubed root of that. The power indicates the numerator, the root indicates the denominator. So since the power is 5, the numerator is 5, and since the root is 3, our denominator is 3. When we get to y, the power is 3, so that's our numerator, and the root is 3, so that's our denominator. That can be simplified to y to the first, because 3 over 3 is 1. Now when we go with our second term, x is being taken to the understood first power, and it's the 4th root, so that's our denominator. And y is being taken to the 5th power, 4th root. So now that we have x to the 5/3, y to the 1st, x to the 1/4, y to the 5/4, we want to go ahead and combine like terms with like bases. So one of the like bases is x to x. So we're going to add our exponents. So we have 5/3 plus 1/4. When we add 5/3 and 1/4, the common denominator between the two would be 12. So this is going to be 20/12 plus 3/12, which is 23/12. So the exponent for x is 23/12. Then we want to add our y terms. Now we have y to the 1st, and we have y to the 5/4. Common denominator is going to be 4. So 9/4 is the exponent for y, and that is your final solution. These next two examples, I want you to go ahead and try on your own, and we will check them when we come into class. So here's example 1, and here's example 2.